Hello students, welcome to the session. So in this session we'll look at the question paper analysis of GATE 2025 of EC branch. Okay. So at the outset I would like to inform that the questions that we have got are memory based questions, right? So all the questions are memory based questions, so the numericals may vary with the actual questions, so please bear with us. So if you look at the weightage of each subject, so you can clearly see that the highest among the technical subject, the highest weightage is for communication. Okay, look at the communication. So for communication, the 2-mark question, they have asked 5 2-mark questions, so therefore 10 marks. Okay, 10 plus 4, right? So 14 marks. Okay, 14 marks alone from communication systems. Okay, and then followed by solid state devices. Look at this one. So you have 10 marks, that is 5 into 2, 10 marks, and 2 1 marks, so therefore 12 marks. Okay, and if you look at the technical subjects, the least weightage is for electromagnetics, right? So this time surprisingly the least weightage is for electromagnetics. Okay, and mathematics and aptitude as usual. Maths, they have asked 13 marks and aptitude 15 marks. Okay, so if you talk about the difficulty level of the paper, listen, we have got around 40 to 45 questions, so still there are 20 questions. We haven't seen those 20 questions, so it is not appropriate to comment on the difficulty level. But from the feedback that we got from the students, most of the students have a common feedback. They have said that aptitude was a bit difficult, but technical part was easier to moderate. Okay, easy to moderate level. Okay, so this was regarding the difficulty level of the paper, and now we shall look at the problem. So look at this one. So first I'll start with network theory. Okay, so consider the following circuit. So a circuit is given to you, and here you are just asked to calculate the Z parameters of the circuit. Okay, so all you need to do here is you just have to convert this to delta network, right? So this is a delta network, so you have to convert into a star network, right? So you have to convert this into a star network. So this is nothing but star network. So what use delta to star transformation, so therefore the value of this resistance will be 2 into 2, 2 into 2 by 2 plus 2 plus 2, right? So therefore 4 by 6, so this is equal to 2 by 3, right? So this is equal to 2 by 3, and the resistors in the delta network are of equal value, so therefore the resistance of the corresponding star network will also be of the same value, that is 2 by 3 ohm, right? So this will also be 2 by 3 ohm, right? So therefore if you redraw the circuit, so this is what you get. So this is 2 ohms and this is 2 by 3 ohms. Okay, this is 2 by 3 ohms. So I will draw the star network with a different color so that you can make out. So look at this one. This is nothing but 2 by 3 ohms. Okay, and this is 2 by 3 ohm, and here you have 2 ohms, right? So this is your 2 ohms. Okay, this is your 2 ohms, right? So therefore now you have got a T network, right? So this is V1, this is V2, this is I1, and this is I2, right? So listen, we know how to write the Z matrix for a T network, right? So therefore these two resistors are in series. Okay, so therefore the net equivalent resistance is nothing but 2 plus 2 by 3 is nothing but 6. 6 plus 2 is nothing but 8 by 3 ohms, right? So therefore this is 8 by 3 and this is 8 by 3 and this is 2 by 3. Okay, now how do you write the entries in the Z matrix? So therefore look at this one. If this is nothing but ZA and this is nothing but ZC and this is ZB, so what will be the first entry? Z11 will be ZA plus ZC, right? 8 by 3 plus 8 by 3 plus 2 by 3, which is nothing but 10 by 3. Okay, and what about Z22? Listen, this is a symmetrical network, so therefore Z11 will be equal to Z22, so therefore this will also be equal to 8 by 3 plus 2 by 3, right? So this 8 by 3 plus 2 by 3, right? What about Z12 and Z21? So Z12 is nothing but 2 by 3 and this is also 2 by 3, right? So therefore the resultant matrix, so if you look at the options, which is a correct answer? C is a correct answer, right? So this is a simple question. So you were asked to find the Z matrix, right? So if assume that you don't know this star to delta conversion or delta to star conversion, right? So what is the other way of solving this particular problem? You just have to solve for each parameter. Z11 is equal to V1 by I1 when I2 is equal to 0. Okay, so apply the equation of a Z matrix, that is V1 is equal to Z11 I1 plus Z12 I2, right? So therefore from this Z11 is equal to V1 by I1 given I2 is equal to 0. So therefore make this I2 equal to 0, right? So make this I2 equal to 0. So if you do that, so you can clearly see that, so look at this one. So this is nothing but I2 is equal to 0. So in that case, what will be the current flowing through these two resistors will be the same, right? So 2 is in series with 2, right? So therefore this will be equal to 4 ohms, right? So equivalent resistance will be 4 and that is in parallel with 2, right? So therefore what will be the net equivalent resistance? So you have 2 here and you have 4 parallel to here, right? So you have 4 parallel to here. So therefore V1 by I1 given I2 is equal to 0. So that will be 2 which is in series with this parallel combination, right? So what is a parallel combination? 2 parallel 4, right? 2 parallel 4. So 2 plus 4 into 2. 4 into 2 is nothing but 8 by 6, right? So therefore this is nothing but 4 by 3, right? So therefore look at this one, 3 into 2 is nothing but 6, 6 plus 4 is nothing but 10, so 10 by 3. So the precisely you got the same result, right? So 10 by 3. So similarly you can do for other parameters as well, right? So this is how you solve this particular problem. Okay, now let us move on to the next problem. So this is again a question from network theory, right? So listen, the questions from the network theory were very simple, right? So all the questions, so these 45 questions are relatively simple, right? So if you ask regarding the difficulty level, when you compare it with the gate 2024, this time questions were on the easier side, right? So as I told you, we haven't seen those remaining 20 questions, right? So these 45 questions are on the easier side. Okay, now look at this particular circuit. So this is the circuit. So this is nothing but 8 volts, right? So this is 8 volts. So there's a printing mistake here. This is nothing but 8 volts. Okay, now you are asked to calculate the voltage at this particular node, at node X. Okay, so this is nothing but node X and you are asked to calculate the voltage at this particular node, right? Now you can clearly see that 1 ampere of current is flowing through this 3 ohm resistor, right? So how do you mark the polarities? Current always flows from higher potential to lower potential, so therefore this is nothing but plus and minus, right? So what is the drop across this 3 ohm resistor? 1 ampere flowing through 3 ohm resistor gives you a drop of 3 volts, right? So what will be the voltage at this particular node? So 9 minus 3 is nothing but 6 volts, right? So therefore the voltage at this particular node is nothing but 6 volt, right? So therefore look at this one, this node is at higher potential, so because when compared to 6, this is at higher potential, right? 8 volts, right? So therefore obviously the current will flow in this direction. So tell me what will be the current flowing through this particular branch? You have two 2 ohm resistor and 1 ohm resistor connected in series. So therefore if I call this current as I, what will be the value of current I? I will be equal to 8 minus 6 by 2 plus 1 is nothing but 3, right? So therefore this is nothing but 2 by 3 amperes, right? So you can clearly see that what will be the voltage at node X? Voltage at node X will be equal to this voltage, right? So this is nothing but voltage at node X with respect to ground. So therefore this is Vx. So this is nothing but 8 volts. Now if you write KVL within this particular loop, what is it that you get? So apply KVL in this particular loop. So you start with 8 and look at this one. The current through 2 ohm resistor is nothing but 2 by 3. So what will be the drop? So minus, current is flowing in this direction, so plus minus, right? Current always flows from higher potential to lower potential. So 2 by 3 amperes flowing through 2 ohm resistor gives you a drop of 2 by 3 into 2, right? So 2 by 3 into 2, right? Minus, so you are applying KVL in this particular loop, so therefore minus Vx is equal to 0, right? So Vx is equal to 8 minus, this is nothing but 4 by 3, right? So therefore 24 minus 4 by 3, 20 by 3 volt, right? So therefore the voltage at node X is nothing but 20 by 3 volts, right? Now let us move on to the next question. Okay, so again this is also a question from network theory. So what is he asking to calculate? In the circuit below, M1 is a ideal AC voltmeter, right? So this is nothing but AC voltmeter, which is reading a value of 25 volts, and M2 is ammeter, and this is reading a value of 5 amperes, right? So the source voltage Vs of t is equal to 100 cos 200t, right? 100 cos 200t. What should be the value of the variable capacitor? So this is a variable capacitor such that the RMS reading on M1 and M2. So look at this, in the voltmeter reads 25 and ammeter reads 5 amperes respectively. So therefore you have to find the value of this capacitance, right? So you are asked to calculate this capacitance. Now listen, these three network elements are in series, right? And what is the voltage applied? So AC source is applied, so therefore you can replace them with their impedance, right? So therefore if you look into this particular terminals, right, so if you look into these terminals, so what will be the equivalent impedance? Impedance will be Z is equal to R plus J omega L plus 1 by J omega C, right? So this you can equivalently write it as R plus J into XL minus J into XC, right? So therefore this is nothing but Z. Okay, so what is the ratio of voltage to current looking into these terminals? So therefore V by I. So if you look at the magnitude of this, so this is nothing but 25 by 5, right? So 25 by 5, which is nothing but 5, right? So therefore this is essentially the magnitude of the impedance, right? So this is nothing but 5 ohms, right? So therefore you know what Z is, right? So therefore take magnitude of Z, so that gives you R square plus XL minus XC whole square. So this is equal to 5, right? The value of R is given. XL, can you find out the value of XL? Yes, because look at this one, XL is nothing but omega L, right? So what is omega given? Omega is equal to 200 radian per second, and the value of L is 1 Henry, right? So now if I square on both sides, what is it that you get? So 5 square plus XL minus XC whole square is equal to 5 square. So therefore 5 square and 5 square will cancel. What is it that you get? So XL is equal to XC, or simply XC is equal to XL, right? So what is XC? XC is equal to 1 by omega C, and what is XL? XL is equal to omega L. So from this you need to calculate the value of C. So C is equal to 1 by omega square into L, right? So the value of L is nothing but 1, right? So therefore 1 by omega square is nothing but 200 radians. So therefore radian per second. So therefore omega square is 200 square into 1. So when you solve it, it comes out as 25 microfarads, right? So this is the procedure for solving this particular problem. Okay, now let us move on to the next problem. So again, you have a question from network theory. So this is very simple, a straightforward question from steady state AC analysis. So you have a parallel RLC network, and a voltage source is connected across this parallel combination, okay, and you are asked to calculate the current through each of these branches, right? Now listen, instead of giving the impedance, they have given you the admittance, right? So that's the only thing that you have to be careful about. So look at this one, admittance is given, admittance of each branch is given to you, okay? You have to calculate the impedance, right? So tell me what will be the capacitive impedance. So look at this one, admittance is given to you, okay? So how do you calculate impedance? Impedance is nothing but the reciprocal of admittance, right? So therefore capacitive impedance is nothing but reciprocal of capacitive admittance. So therefore admittance is given as J.25, right? So therefore 1 by J I can write it as minus J, and 0.25 I can write it as 1 by 4. So therefore this becomes minus J4 ohms, right? So therefore what is the current through the capacitor? IC is equal to, listen, since all the elements are in parallel, so the voltage across all the network elements will be the same. So therefore IC is equal to 1 angle 90 degrees divided by, so what is the impedance? Impedance is nothing but minus J4. So I can write this as 4 angle minus 90 degrees, right? Minus J I can write it as minus 90. So therefore 4 angle minus 90. So therefore you have both the quantities in polar form. So 1 by 4 is nothing but 0.25, and this minus 90, when it goes to numerator, it becomes 180, right? So therefore in which options do you find this? So straight away you can see this in option A, right? So therefore you don't have to calculate the other two values, right? So listen, directly IC is equal to 0.25 angle 180 degrees. Now you have to follow the same procedure for calculating the current through the inductor and the resistor, right? So I want every one of you to solve the current through the inductor. So what will be the current through the inductor? So 1 angle 90 degrees divided by what is the inductive impedance? So inductive impedance ZL is equal to 1 by, so what is the inductive admittance given to you? So this is nothing but minus j 0.15, right? So therefore this is nothing but j by 0.15, right? J by 0.15. Now look at this one. So this is nothing but this is equal to this is nothing but j by 0.15, right? J by 0.15. So therefore this you can write it as angle 90 degrees. So therefore that becomes 0, and this 0.15 when it goes to numerator, so this is equal to 0.15 angle 0 degrees. So therefore you can clearly see it should be 0.15, right? So it should be 0.15. Now similarly follow the same procedure for calculating the current through the resistor, right? So this is a simple straightforward question. Now let us move on to the next question. Now listen, those were the questions from network theory. Now we shall look at the questions from analog electronics, right? Now look at the question. So a circuit is given to you, okay? A circuit is given to you and you are asked to calculate the value of this VCE, right? So DC analysis, you have to perform the DC analysis of this particular biasing circuit. So VCE, so in order to calculate VCE, what is it that we do? So we write KVL at the output loop, right? We write KVL at the output loop. So this current is nothing but IE, and obviously this current will also be equal to IE, right? So therefore if you write KVL at the output loop, I'll start with 10, okay? 10 minus, so I have assumed the current flowing in this direction. So since this is IE, this will also be equal to IE. So current is flowing in this direction, mark the polarities. Current is flowing in this direction, so similarly mark the polarities, right? So 10 minus 5k, right? 10 minus 5k into IE, right? Minus VCE, right? Minus VCE minus look at this one, you are moving from higher potential to lower potential. That's the reason why I have placed this negative sign here, right? So minus IE into 3k, right? So this is equal to 0. So what is it that we have to calculate? VCE, right? So VCE is equal to, look at this one, you have IE common in both these terms, right? So therefore this becomes 10 minus 8k, right? So 10 minus 8k into IE, right? Now how do you calculate IE? Listen, IB is given to you and beta is also given to you. So therefore IE is equal to beta plus 1 into IB, right? So therefore beta is nothing but 100. So therefore 101 into IB is nothing but 10 microamperes, right? So therefore this is the value of IE. Just substitute into this equation and solve for VCE. It comes out as, so we have already solved this, it comes out as 1.92 volt, right? It comes out as 1.92 volt, right? So this is again a very simple problem from analog electronics, right? Now look at this particular question, again a question from analog electronics. So a circuit is given to you, okay? A circuit, a small signal equivalent is already given to you and you are asked to calculate the voltage gain, right? So V0 by Vs, okay? Now listen, this is beta IB. So what will be the voltage V0? V0 is nothing but the voltage across the resistor RL. So this is nothing but V0. So what will be this current? This current will be equal to minus beta IB, right? So if this is beta IB, so this will be minus beta IB. So obviously this beta IB has to flow through this resistor RL, right? So therefore V0 is equal to minus beta IB into RL, right? Now IB, listen, you need a relationship between V0 and Vs, right? So therefore what is IB here? So in order to calculate IB, you just have to look at the input side, right? So therefore IB, look at this one, the current flowing through these two resistors is nothing but IB. So therefore these two resistors are in series, right? So therefore what is the voltage across these two resistor combination? They are in series, and the voltage across this series combination is nothing but Vs, right? So therefore IB is nothing but Vs by Rs plus R pi, right? So all you need to do is you just have to substitute IB with this value, right? So therefore V0 is equal to minus beta into IB is nothing but Vs by Rs plus R pi into RL, right? So get the ratio V0 by Vs. So this is nothing but minus beta RL divided by Rs plus r pi, right? So choose the correct option from the set of options, right? So therefore this is how you solve this particular problem. Okay, now let us move on to the next question. So this is again a question from analog electronics, right? So look at this one. A clipper circuit is given to you, okay, because you just have resistor and diode, right? So therefore this is nothing but a clipper circuit. So for the circuit of diode shown in the figure below, the on time of the diode, right, the on time of the diode in milliseconds, right? So listen, he has asked you the question in milliseconds, so be careful while entering the answer. Okay, now look at this one. So I want to find out the duration in which this diode will be on, right? So therefore I will apply, listen, there is no information given regarding the diode, so therefore I'll assume it to be an ideal diode, right? So therefore what will be the condition for this diode to be on, right? So let us apply the short circuit test. So therefore I'll assume the diode to be on, right? So I am replacing the diode with the short circuit, right? So I have replaced the diode with the short circuit. Now listen, when we assume the diode is forward bias, obviously the current flows from P to N, right? So therefore this is a current, right? So therefore if this is a current through this particular branch, so the same current flows through this branch as well. So therefore this is your applied input, this is your resistance, and this is nothing but 5-volt battery, right? So therefore this is minus and this is plus, right? Now I want every one of you to write the equation for I, so current flowing in this particular loop, right? So all you need to do is apply KVL in this particular loop, since current is flowing in this direction. So apply, so mark the polarity. So this is plus and this is minus, right? So V in minus IR, right? So plus 5 is equal to 0, right? So from this I is equal to V in plus 5 by R, right? So listen, we have assumed that the diode is forward bias, so therefore obviously this current has to be positive, right? So therefore I should be positive, that is this has to be positive, right? So therefore what is the condition that we get? So V in plus 5 greater than 0, or V in should be greater than minus 5 volt, right? So what is the input given to you? Input given to you is nothing but, so V in they have already given to you, which is nothing but 10 sine 100 pi t, right? So this is what is given to you. Okay, now let us use this condition. So look at this one. So listen, the diode, first let me draw the input. So if you draw the input, so this is what you get. Okay, so this is a sinusoidal signal of peak amplitude 10 volts, peak to peak you have 20, right? So therefore this is 10 and this is minus 10. Okay, so for all the input voltage greater than minus 5, so I will also mark minus 5. So minus 5 is somewhere here, right? So this is nothing but minus 5 volt. Okay, so for all the input voltage, so this is nothing but your input voltage versus time, right? So for all the input voltage greater than minus 5, the current will be positive, implying that the diode will be on, right? Implying that the diode will be on. So therefore the diode will be on for this much duration, right? So during this time and during this time, right? So therefore you need to calculate this one, right? So therefore in one time this is one time period, right? So this is one time period. So therefore you in one time period what is the duration for which the diode will be on, right? So that's a question, right? So therefore you need to calculate this one, right? So this duration and this duration, right? So how do you do that? So tell me first, what is the time period of the given input? So how do you calculate the time period? Because look at this one, omega is nothing but 100 pi, right? So therefore this is nothing but 2 pi by t is equal to 100 pi. So therefore t is equal to, so t is equal to 2 by 100, right? 2 by 100. So therefore this you can write it as multiply with 10 in the numerator and denominator. So therefore you can write this as 20 milliseconds, right? So one time period, so this complete time period is nothing but 20 milliseconds, right? So half of that, so this is nothing but, this value is nothing but 10 milliseconds, right? So this is nothing but 10 milliseconds. And now you need to find this interval, right? So this interval, and similarly this interval, right? So this interval. So how do you do that? So listen, you have to pick that instant at which the input voltage becomes minus 5, right? So therefore take out your input. So what is your input given? 10 sine 100 pi t is equal to, so listen, the diode turns off when the input voltage goes below minus 5 volt, right? So therefore this is the limiting value, right? So therefore you have to find the value of t. So so at t is equal to t1, so this is the value t1, right? So this instant is nothing but the value t1. So therefore at this particular value the input becomes equal to minus 5, and solve for this t1, right? So how do you do that? So sine 100 pi t, is equal to minus 5 by 10, which is equal to minus 1 by 2, right? So therefore listen, when does the sine function become equal to minus 1 by 2? So look at this one, when the argument, so 100 pi t is equal to, so look at this one, this is pi and this will be equal to pi, listen, the sine function becomes half when it is 30 degrees, right? So therefore pi plus pi by 6, right? So pi plus pi by 6. So from this you get the value of t1, right? So t1, it comes out as, look at this one, pi 100 pi t1 is equal to, this is nothing but 7 pi by 6. So pi and pi will cancel. So therefore what is it that you get? So this is nothing but t1 is equal to 7 by 6 into 100. So I'll multiply with 10 in the numerator and denominator. So therefore 70 by 6 milliseconds, right? 70 by 6 milliseconds. So it is around 11 points. So if you solve this, it comes out as 11.6, okay, 11.66 milliseconds, right? So therefore listen, this time instant is nothing but, so t1, so this interval, so this value is nothing but, I'll draw it properly so that you can see this clearly. So this is your input, right? So this is your input and this is the reference level, okay? This is the reference level, which is nothing but minus 5 volt, okay? So you have to find this particular instant. So this is the instant that you need to calculate, right? So we have calculated that this value, this t1, so this instant t1, so t1 we have got it as 11.66 milliseconds, right? And we know that this value is nothing but 10 milliseconds, right? So therefore this duration, this is nothing but 1.66, right? So 1.66. So therefore look at this one, this duration, that is 11.66 minus 10. So 11.66 minus 10 milliseconds is nothing but 1.66, right? So t1 is nothing but 11.66. So t1 minus half the time period is nothing but 1.66 milliseconds. So why did I do that? Because listen, this duration will also be symmetrical as that of this one, right? So therefore this will also be equal to 1.66, right? So therefore the total duration for which the diode gets on is nothing but, so this time period plus this interval plus this interval, right? So therefore 10 milliseconds plus 1.66 milliseconds plus 1.66 milliseconds, right? So together it gives you 13.33 milliseconds, right? So this is how you solve this particular problem, right? So listen, how did we calculate the value of t1? So all we have done is we have equated the input to minus 5. I got the value of t1. So t1 I got it as 11.66 milliseconds, right? So therefore I got the value of t1 as 11.66 milliseconds, right? So therefore I know the half time period, which is nothing but 10 milliseconds. So therefore the duration, so this interval is nothing but 1.66 milliseconds, right? So since this is a sinusoidal waveform, this duration, this interval will also be symmetrical, right? So therefore this is also 1.66 milliseconds, right? So listen, what we need is the duration in which the diode gets on, right? So therefore the diode will be on for this interval as well as this interval, right? So in one time period, so this is the duration in which the diode gets on, right? So for all the input voltage greater than minus 5 volt, right? So therefore this is how you calculate the value for which the diode gets on, right? So the answer is 13.33 milliseconds, right? Now let us move on to the next question. So this is a straightforward question, okay? A bridge rectifier is given to you and you are asked to plot the transfer characteristics, right? So you just have to listen, this is a full wave rectifier, so obviously the transfer characteristics, so transfer characteristics is a plot between the input voltage and the output voltage. So obviously this will be the transfer characteristics which we have discussed n number of times in our classes, right? So therefore the option is nothing but B, right? So if it is half wave rectifier, then it would have been like this, right? So if it was half wave rectifier, then the transfer characteristics would have been line like this, right? So this is a linear line, so this is also a straight line, right? So this is also a straight line. Okay, so the correct answer to this particular question is option B. Okay, now let us move on to the next question. So look at this particular problem. He is asking you to find the value of R1 and R2. So the value of R1 and R2 are given in the options. We assume that this is a MCQ and the value of R1 and R2 are given in the options, right? So look at this one. So how do you calculate the value of R1 and R2? What is the information given to you? VEB1. So you have two PNP transistors. So VEB1 is nothing but 0.7 and VEB2 is also 0.7. Beta is given to you 120 VZ. The voltage across the Zener diode is 5 volt. The current through the Zener diode is 25 milliamperes. The load current, so where is so this is nothing but the load, right? So this is nothing but load. So this is your load, and the current through the load IL is nothing but 12 milliamperes, right? So this is what is given to you, and you are asked to calculate the value of R1 and R2, right? Now how do you do this? So listen, we are given the value of VEB, right? So therefore this is nothing but 0.7 volt, right? So this node voltage is 20 volts, right? So 20 minus 0.7. So what will be this node voltage? So what will be this node voltage? 20 minus 0.7. So listen, so if I call this node voltage as V, so all you need to do is apply KVL. So 20 minus 0.7 minus V is equal to 0. So V is equal to 20 minus 0.7, which is equal to 19.3 volts, right? So this is nothing but 19.3 volts. Okay. Now what about this one? Listen, if you want to find the value of R1, you need to get the voltage across R1 and current through R1, right? So that's what I'm going to find, right? So first, listen, we need to find the value of R1 and R2. All you have to do is get the ratio of voltage and current across R1 and R2. Okay. Now look at this one. So what will be this node voltage? This voltage is nothing but 19.3, and what about the voltage across the Zener diode, which is nothing but 5 volts. So therefore 19.3 minus 5, 19.3 minus 5 will be the voltage across R1, right? So therefore this is, listen, this is the network element. This is the only network element between this node and ground, right? So therefore the voltage across this particular resistor, I'll call it as VR1. Okay, so look at this one. This node voltage is 19.3. 19.3 minus 5 is nothing but 19.3 minus 5 is nothing but VR1, right? So VR1 is equal to 14.3 volt, right? So this is nothing but 14.3. So I got voltage across the resistor. Now I need to get the current through the resistor, right? Now how do you find that? So listen, the current flowing through this particular branch IZ is given to you, which is given as 25 milliamperes, right? So what is the current flowing through IB? So look at this one. What is the current flowing through this particular branch? What is the current IB? So can you calculate IB? Yes, because listen, IL, the collector current is given to you. Okay, the collector current is given to you, which is nothing but 12 milliamperes, and the value of beta is also given to you. So therefore IC is given to you and beta is also given to you. So therefore IB is nothing but IC by beta. So what is IC? IC is nothing but IL, which is equal to 12 milliamperes, divided by beta is nothing but 120. So therefore this is 0.1 milliamperes, right? So look at this one. This is 0.1. The current flowing through this particular branch is 0.1 milliamperes, and the current flowing through this particular branch is 25 milliamperes, right? So therefore when you apply KCL at this particular node, 25 milliamperes coming from this particular branch and 0.1 milliamperes coming from this particular branch, right? So this is 25 milliamperes and this is 0.1 milliamperes. So what will be the current through this particular branch? 25 plus 0.1, 25.1 milliamperes, right? So therefore I got the voltage across the resistor R1, and also I got the current through the resistor R1, right? So IR1 is nothing but what is the current? So 25.1 milliamperes, right? So all you need to do is to find the value of R1, get the ratio of V by I, right? So therefore VR1 by IR1, so this is nothing but 14.3 by 25.1 milliamperes. So therefore when you solve that, the value of R1 comes out as 0.56 kilo ohms, right? So 0.56 kilo ohms, right? So this is how you calculate the value of R1, right? Now follow a similar procedure for calculating R2, right? So again, I am interested in calculating the voltage and current across R2, right? So now listen. So what is the current through this emitter terminal? Listen, IC or IL. So this is nothing but IC. So IC is nothing but 12 milliamperes, and beta is very large, right? So beta is very large. So therefore, using the value of IC and beta, you can calculate IE, right? So when you calculate it, IE also comes approximately equal to 12 milliamperes, right? So you know the relationship between IE and IC, right? So beta is also given to you. So therefore, IE also comes out as approximately equal to 12 milliamperes, right? So the current through the R2 is nothing but 12 milliamperes, right? Now what is the voltage across R2? That is what we need to calculate, okay? Now listen, the voltage at this particular node is nothing but 14.3, right? So this is nothing but 14.3, okay? The voltage at this node, so this node voltage is 14.3 and this voltage is nothing but 0.7, right? So I need to get this voltage, right? So this is nothing but VE, right? So all I am going to do here is I'll apply KVL along this particular loop, right? So I'll start with VE minus 0.7 and this is 14.3, right? So minus 14.3 is equal to 0. So therefore VE is equal to 15 volts, right? So therefore this node voltage is nothing but 15 volts. So look at the both ends of R2. At one node the voltage is 20 volts, at the other node the voltage is 15 volts. So therefore the potential difference is nothing but 20 minus 15, which is nothing but 5 volts, right? So therefore the voltage across resistor, R2 is nothing but 5 volt, and the current through the resistor R2 is nothing but 12 milliamperes. So all you need to do is get the ratio to find the value of R2. So therefore 5 by 12 milli, that gives you 0.41 kilo ohms, right? 0.41 kilo ohms. So this is how you solve this particular problem, right? So listen, here we have only used KCL and KVL, right? Nothing more than that. So this is how you solve this particular problem, okay? Now let us move on to the next problem. So in the given differential amplifier, again this is a question from analog electronics. So in the given differential amplifier, output V3 is equal to, so this is a differential amplifier circuit, and look at the output. So output is taken from only one node, right? So therefore this is nothing but unbalanced output, right? So unbalanced output, okay? Now the value of transconductance is given to you 5 millisiemens, okay, and you are asked to calculate the value of V3, and in the options they have given V3 as sum of DC plus AC, right? So sum of DC plus AC, so therefore you need to get the total voltage at this particular node, right? So how do you do that? So listen, I will do the DC analysis separately and AC analysis separately, okay? So now listen, when you consider the DC analysis, so you can deactivate the AC sources. So therefore what you have is 2.5 volts applied at both ends. So therefore listen, both of them will behave similarly. So therefore look at this in the current, this total current is nothing but 2 milliamperes, right? And both the voltages are 2.5 volts, right? So when you perform DC analysis, this is 2.5 and this is 2.5, and this total current is 2 milliamperes. It means that this is 1 milliampere and this is 1 milliampere, right? So listen, the current through the drain is 1 milli, so therefore this current is also 1 milliampere, right? So I need to get V3, right? So all I need to do is apply KVL along this particular path, okay? KVL along this particular path. So I'll start with 5. Current is flowing in this direction, so mark the polarities plus minus, right? So 1 milli into 1k, so this is nothing but 1. So this is the voltage at this particular node with respect to ground, so therefore minus V3 is equal to 0. So V3 is equal to 4 volt, right? So therefore the DC part of V3, so the DC value of V3 is nothing but 4 volt, right? Now similarly you have to perform the AC analysis. So this is DC and you have to perform AC analysis, right? Now if you carefully observe this, this is nothing but differential amplifier with unbalanced output, right? So in this case we have already calculated the differential gain for unbalanced output, right? So unbalanced output, the differential gain is nothing but minus GM RD by 2, right? So this is for unbalanced output, right? So unbalanced output. Now for balanced output, what is the differential gain? For balanced output, what we have learned is V naught by Vd is nothing but minus Gm into Rd, right? So listen, what is a balanced output? So if the output is taken like this, then then that is nothing but balanced output. Now here the output is taken from one node, so therefore this is nothing but unbalanced case, right? So this is unbalanced case, so therefore we need to use this particular formula. Okay, now look at this one. So Gm is given to you and Rd is also given to you. Okay, so therefore V naught, so listen, this is nothing but V naught is equal to V3. So what is Vd? Vd is nothing but 0.01 sin omega t. So Vd is nothing but, look at this one, 0.01 sin omega t minus the difference between the inputs, right? So therefore minus 0.01 sin omega t, right? So therefore this is nothing but 0.02 sin omega t, right? So therefore this is nothing but Vd. Vd is nothing but 0.02 sin omega t, right? So here listen, they are not asking you to find the gain, they are asking you to find the voltage, right? So therefore you use this formula to find the voltage at this particular node. So V3 by the difference between the inputs is nothing but this one, so this is equal to minus Gm. Gm is nothing but 5 milli, so minus 5 into 10 raised to minus 3 into Rd, the value of Rd is nothing but 1k by 2, right? So this kilo and milli will cancel. So what is it that you get? So V3 is equal to minus 2.5 into 0.02 sin omega t, right? So therefore this is nothing but the AC part, right? So you got the DC part as well as the AC part, right? So this is how you solve this particular problem, right? Now let us move on to the next question. So again a question from analog electronics. So find the high frequency if the lower cutoff frequency is 1 megahertz, right? So the upper cutoff frequency, you are asked to calculate the upper cutoff frequency, lower cutoff frequency is given to you, right? So which filter is this? So when omega is equal to 0, the capacitive impedance will be 1 by j omega c, that is it behaves as open circuit, right? It behaves as open circuit, so therefore input is no longer connected to the circuit, so therefore V naught is equal to 0, right? Omega infinity, the capacitive impedance will be equal to 1 by j omega c will be 0, that is short circuit, so therefore listen, this resistor R2 will lose its significance, so therefore listen, this 0 volt will appear at the output, so therefore V naught is equal to 0. So look at this one, when omega equal to 0, V naught is equal, output is 0, when omega equal to infinity, output is 0. So essentially this is a band pass filter, right? Essentially this is a band pass filter, right? So band pass filter. So what is the information given to you? The lower cutoff frequency is given to you. Okay, this is nothing but the lower cutoff frequency FL, and you are asked to calculate the upper cutoff frequency FH, right? So therefore this is what you are asked to calculate, right? So listen, you can clearly see that this shunt arm, okay, this shunt arm, so this shunt arm decides the upper cutoff frequency. Okay, this shunt arm decides the upper cutoff frequency, right? This decides the upper cutoff frequency, so therefore 1 by 2 pi R2 C2, okay, and the series arm decides the lower cutoff frequency, right? So 1 by 2 pi R1 C1. Okay, so this is given to you, which is nothing but 1 megahertz. Okay, so FL is equal to 1 by 2 pi R1 C1, right? So the value of R1 is given to you, R1 and C1 is given to you, so therefore this is equal to 1 megahertz, right? So 1 by 2 pi R1 is nothing but R and C1 is nothing but 10 into C, right? So therefore this is equal to 1 megahertz. Okay, so 1 by 2 pi RC is equal to 10 megahertz. Okay, so therefore this is given to you. Okay, now you have to calculate the upper cutoff frequency. So therefore look at this one, this is nothing but FH is equal to 1 by 2 pi R2 is nothing but 2R, right? So this is 2R into C2 is nothing but 0.1 into C. Okay, so you can clearly see that this is equal to 0.2 into, this is nothing but 1 by 0.2 into 2 pi RC, right? We know that 1 by 2 pi RC is nothing but 10 megahertz, right? So therefore 10 megahertz divided by 0.2, right? So therefore that comes out as 50 megahertz, right? So the value of the FH is nothing but 50 megahertz, right? So the answer to this particular question is 50 megahertz. Okay, this is how you solve this particular problem. Okay, now let us move on to the next question. Identify the correct statement regarding ideal op-amp. So the properties of ideal op-amp is given to you. You have to pick the correct statements. Okay, output impedance is infinite. No, output impedance of ideal op-amp is 0, right? So input impedance is infinite. Yes, this is true, right? So this is essentially a MSQ, right? Multiple select questions. So input impedance of ideal op amp is infinite. Open loop common mode gain. So open loop common mode gain. So this ideally it should be 0, right? So therefore statement C is also wrong. Okay, ideal open loop differential mode gain is AD. Ideally it should be infinity, right? So CMRR ideally should be infinite, right? So it should be infinite. So therefore AD should be infinite and a differential gain should be infinite and common mode gain should be equal to 0. So therefore D is also correct, right? So this is a multiple select question, so therefore B and D are the correct options, right? Now let us move on to the next question. So again this is again a multiple select question. Okay, so what is the information given to you? Common source amplifiers has infinite input resistance. So listen, common source, so this is nothing but the MOSFET. Okay, so this is a gate terminal, this is a source terminal, and this is a drain terminal, right? So common source, so therefore source will be grounded. So input is applied to gate and output is taken from, so this is the input applied to gate and output is taken from drain. So you can clearly see that since input is applied at the gate terminal, we know that there is an insulating layer at the gate terminal. So therefore the current into the gate terminal is nothing but 0. So Ig is equal to 0 amperes, and therefore I can conclude that the input impedance is infinite, right? So therefore for common source amplifiers the input resistance is infinite. Okay, common gate amplifiers has infinite. So listen, in the case of common gate, what will be the, where will you apply the input? So gate will be grounded, input is applied at the source and output is taken from the drain, right? So this is where you apply your input, and this is where you take your output. Okay, so now listen, when you look into the source of a MOSFET, what is the resistance? So this is nothing but 1 by GM, right? 1 by GM. So therefore we have already discussed this. So this is nothing but 1 by GM. So therefore this is finite, right? So therefore common gate amplifiers has infinite input resistance. This statement is false. Okay, V in and V naught of common drain amplifiers are in phase, right? So listen, we have 180-degree phase shift only for common source amplifiers, right? So for common drain and common gate, there is no phase shift between the input and output. So therefore statement C is correct. V in and V out of common source amplifiers are in phase. No, right? So they are out of phase by 180 degrees. So therefore the correct options are A and C, right? So this is how you understand these points, right? So therefore options A and C are correct. Okay, now look at the next question. Now we have questions from signals and systems. Okay, let x of n be a discrete time signal whose z transform is x of z. So x of n and x of z forms a z transform pair. Which of the following statements are true? Again you have a multiple select question. Okay, multiple select questions. So listen, more than one answers will be correct. So you have to read the questions, each of these options carefully. Look at this one. DTFT exists if the ROC contains unit circle. Yes, right? Statement A, option A is correct. DTFT exists if ROC, the region of convergence, contains the unit circle, right? DTFT of x of n always exists. No, DTFT of x of n exists only if the ROC includes the unit circle, right? So therefore option B is wrong. Okay, ROC of x of z contains neither poles nor zeros. ROC of x of z should not contain poles, but there is no condition on zeros, right? So ROC can contain zeros, right? So therefore option C is also false, right? ROC does not contain poles, that is correct, but there is no restriction for zeros, right? So therefore ROC can contain zeros, so therefore option C is also false. If x of n is alpha del of n is a unit impulse del of n is nothing but unit impulse and alpha is a scalar, then ROC is entire z plane, right? So this is a finite duration signal because listen, del of n exists only at n is equal to 0, right? So this is nothing but this is just scaled by, so del of n, the amplitude at n equal to 0 is 1, so now it is scaled by alpha, right? 1 into alpha is alpha. So this is a finite duration signal, and we have learned that for finite duration signal the ROC is entire z plane, so therefore option D is also correct. So therefore the correct options are A and D, right? So this is how you analyze the question. So now let us move on to the next question. So this is nothing but y of t is equal to, listen, you have two periodic signals, okay, because you can clearly see that the Fourier series representation is given to you. So this, there is a printing mistake here, so this is essentially plus, right? So ck into e raised to j n omega naught t, dk into e raised to plus j n omega naught t, right? Now listen, how are these two signals related? So y of t is equal to f of alpha t, right? So if this is a relationship between these two signals, how are their Fourier series coefficients related, right? So scaling property, we have already learned that, listen, if x of t has Fourier series coefficient Cn, what will be the Fourier series coefficient of x of alpha t? So the Fourier series coefficient of x of alpha t is also Cn. The only thing is that the signal in the frequency domain gets scaled, right? The signal, that is the signal in the time domain has compressed, right? So if alpha is greater than 1, the signal in the time domain has compressed, obviously the signal in the frequency domain will expand, right? So therefore if omega naught is a fundamental frequency of the x of t, what is the fundamental frequency of x of alpha t? So that will be alpha omega naught, right? So this is fundamental frequency. What about the fundamental period? So if this is t naught, so this will be t naught by alpha, right? So this is what the scaling property, okay, very very important. So therefore what is the first option? Ck is equal to dk for all k, right? So this is correct, okay. Ck is equal to alpha, dk no, right? So ck, that is the Fourier series coefficient of the both the signals x of t and x of alpha t, both are the same, right? So if time period of f of t is t naught, the time period of f of alpha t is t naught by alpha, yes, right? So option C is correct. So here if time period of f of t is t naught, the time period of f of alpha t is no, right? So the signal in the time domain gets compressed, right, whereas the signal in the frequency domain gets expanded, right? So therefore option D is incorrect, right? So the correct options are A and C. Now let us move on to the next question. So this is a MCQ, right? So if it is MCQ, now look at this one. So f of omega, so this is nothing but the definition of Fourier transform, right? So f of omega is equal to minus infinity to plus infinity, f of t e raised to minus j omega t dt. Okay, now look at the option. So listen, he is asking you to find the condition for the existence of Fourier transform, right? So when you take the magnitude, right, when you take the magnitude, so what is it that you get? So f of omega, so this, listen, for this to exist, so what should be the condition? So this should be a finite value, right? This should be a finite value. So therefore magnitude of f of omega should be less than or equal to this one, right? So because magnitude of e raised to minus j omega t is nothing but magnitude of complex exponential is nothing but 1, right? So therefore this is a correct answer, right? This is a correct answer. Listen, if this is MCQ, this is a correct answer, right? So now if you look at the other options, magnitude of f of omega, so look at option B. So what is this value actually? So if you substitute omega equal to 0 into this, what is it that you get? So f of omega at omega equal to 0, so this is equal to integral minus infinity to plus infinity f of t dt, right? So therefore this is nothing but area under the signal. If you want to find the area under the signal, you just have to look at the signal in the other domain at omega equal to 0, right? So look at this one, this is nothing but, so if you look at option B, so this is magnitude of f of omega and this is given as magnitude of f of omega at omega equal to 0, right? So listen, suppose if for example you have a Fourier transform of a signal like this, right? So this is a Fourier transform of a signal, so this is omega and this is f of omega, right? So you can clearly see that at omega equal to 0, the amplitude is nothing but, say, assume that this is 1, and at omega equal to 3, say you can clearly see that this is, say this is 5, right? So therefore you can clearly see that this is a possible spectrum, right? So therefore this is also correct, right? So the other two statements are false, right? So therefore this can also be the answer, right? So D is definitely the answer and B can also be the answer, right? Now let us move on to the next question. So now we have questions from control systems. The characteristic equation of a system is given to you. Okay, characteristic equation of a system is given to you. L is defined as the number of roots on the negative real axis. I is defined as the number of roots on the imaginary axis, and R is defined as number of roots on the positive real axis. Then which of the following options are correct? Okay, which of the following option is correct? Okay, now this is your characteristic equation, so therefore I have to use the RH criteria. So therefore I will first develop the data table, route table. So therefore s raised to 5, s raised to 4, s raised to 3, s raised to 2, s raised to 1 and s raised to 0. Okay, so what will be the entries in the first row? 1, 3, 2, right? 1, 3, 2. And what about the entries in the second row? 7, minus 33 and minus 40, right? So all of you please pause the video and try to enter the entries in the third row. Look at this one. 7 into 20, 7 into 3, 21, 21 plus 33, right? So because minus into minus becomes plus, so by 7. So this is nothing but 54 by 7, right? So 54 by 7, it comes out as 7.71. Okay, now what will be the next entry? So 7 into 2, 14, 14 minus of minus 40 is nothing but minus of minus becomes plus, right? So therefore plus 40 by 7, so therefore 54 by 7, this is nothing but 7.71. Okay, now the entries in the next row, what will be the entries in the next row? 7.71 into minus 33, okay, minus 7 into 7.71 divided by 7.71. So you can take 7.71 common from the numerator and denominator and strike it off. So therefore what is it that you get? So it comes out as minus 33 minus 7, which is nothing but minus 40, right? And you can copy this minus 40 here, right? So therefore this is minus 40. Okay, now so if you solve this, that is, if you fill the entries of the next row, this is nothing but minus 40 into 7.7 plus 40 into 7.7. So therefore this is 0. So what you get is a row of 0, right? Because you have only one entry in this particular row. So therefore this is 0 and therefore you get a row of 0, right? So obviously you have to develop the auxiliary equation, right? So auxiliary equation, so you just look at the row above, right? So therefore this auxiliary equation is nothing but minus 40 s square minus 40 is equal to 0, right? So in order to fill this row of 0, you just have to differentiate this auxiliary equation. So when you differentiate the auxiliary equation, what is it that you get? So minus 80 s, right? So minus 80s minus 0, right? So therefore the row of 0 will be replaced with minus 80, right? And what will be the entry in the last row? Minus 40, right? So this will be copied as it is. So this is your, so we have completed the data table, that is route table. Now we have to analyze this. Okay, now you can clearly see that we have learned that the roots of the auxiliary equation are nothing but the closed loop poles, right? So therefore first we shall find the roots of the auxiliary equation. So therefore this is your auxiliary equation. Now I will take minus 40 common. So what is that you get? So s square plus 1 is equal to 0, that is s is equal to plus or minus j. So therefore I can conclude that two of the closed loop poles are on the imaginary axis, right? So therefore two poles are on the imaginary axis exactly at j and minus j, right? And how many sign changes do you find in the first column? There is only one sign change, right? There is only one sign change in the first column. So therefore I can conclude that there is only one root in the right half of the S plane, right? So there is only one closed loop pole in the right half of the S plane, right? Now you can clearly see that since the sign change is above the auxiliary equation, there will be no symmetrical pole in the left half of the S plane to the pole placed in the right half of the S plane, right? So it means that if you look at the degree of the characteristic equation, it is 5, right? So therefore out of 5, closed loop poles, we have already located 3 closed loop poles. So therefore obviously the remaining 2 poles should be in the left half of the display. And listen, these poles need not be symmetrical because the sign change is above the auxiliary equation, right? So therefore I can conclude that the number of poles in the left half of the S-plane is equal to 2, the number of poles on the imaginary axis is equal to 2, and the number of poles in the right half of the S-plane is equal to 1, right? So this is L, so L is equal to 2, okay, on the negative real axis, I is equal to 2 and R is equal to 1, right? So therefore option B is correct, right? So this is how you solve this particular problem, okay? Now consider the system shown below. Okay, so a system is given to you and g of s, so the plant is 1 by s square k of s. So this is nothing but your controller. Okay, this is nothing but your integral controller. Now if I place a integral controller in the feed forward path, what is the statement that he has given? The system will never be stable, right? So okay, let us use this one. So this is nothing but 1 by s, so therefore when you cascade it, it becomes 1 by s cube. So therefore c of s by r of s is nothing but 1 by s cube plus 1, right? So characteristic equation is nothing but s cube plus 1 is equal to 0. So you have missing terms in the characteristic equation. There is no s square term, there is no s term, right? So therefore obviously I can conclude that the system is unstable, right? Unstable. So therefore statement 1 is correct. Okay, statement 1 is correct. Okay, so listen, you are asked to identify the correct statements, right? So therefore if k of s, so if this is used, I can directly conclude that the system will never be stable. Okay, now look at this one. If k of s is nothing but kp plus s into kd, so this is nothing but PD controller, right? So this is nothing but PD controller. So what does a PD controller essentially do? It adds a 0, right? So when it adds a 0, what happens to the system? The system becomes stable, right? The system becomes stable. Listen, why do we use PD controller? It improves the transient response, also it improves the stability of the system, right? So therefore if you use a integral controller, the system will never be stable, and if you use a PD controller, okay, PD controller, then the system becomes stable because it adds a finite 0, right? So therefore option A, that is statement 1 and 2 both are true, right? So therefore option C is the correct answer. Okay, now let us move on to the next question. Consider the system having block diagram. Okay, listen, what is the question? Which of the following figure has same transfer function? So apply Massengian formula blindly. Okay, so C of s by R of s. So listen, how many forward paths do you find in this particular block diagram? So this is G1. Okay, this is G1 and this is G2. Okay, this is G2, so G1 plus G2. Okay, and how many loops do you find here? So this is the only loop that you have, right? This is the only loop that you have, so therefore 1 plus G1, right? 1 plus G1 because the feedback is negative, right? So this is negative, right? So therefore G1 plus G2 by 1 plus G1, right? Now you have to check it for each of these options. So I think this is a MSQ question, so therefore sorry, MCQ question, right? So this is MCQ question. So we shall do it for the first option. So look at this one. This is nothing but the first forward pass, so G1, and this is the next forward pass, so this is G2, right? So listen, there are no non-touching loops, right? So look at this one. This is nothing but 1 plus G1, right? This is 1 plus G1. Now do you find any other loop? No, right? There is no other loop. So therefore for option 1 you get the same transfer function as that of this one, right? So therefore option A is correct. Now what about option B? Option B, this is nothing but G1, right? So this is the first forward path, and G2, this is the second forward path. And do you have any loop? Yes, right? So this is one loop. So 1 plus G1, and you also have one more loop, right? So which is nothing but G2, right? So which is incorrect, right? Now similarly you can also check it for option C and D. This will not get transfer function similar to this one, so therefore the correct answer is nothing but option A. Okay, now let us move on to the next question. So consider an open loop system with which has a root locus as shown in the figure. Okay, find the value of k for which -1 plus j lies on the root locus, right? -1 plus j lies on the root locus. Now you can clearly see that you can clearly see that, listen, -1 plus j is at this particular point, right? So if this is nothing but j1, so this is the point. So listen, you can clearly see that this point is not on the root locus, right? So for no value of k, the root locus passes through this particular point, right? So there is no value of k at which the root locus passes through this particular point, because you are given a system and the root locus of that particular system is already given to you, okay? And you can clearly see that this is a point that they are asking you to find the value of k, right? So at this particular value, at this particular point, they are asking you to find the value of k, right? So clearly the root locus will never go through this particular point. So therefore there is no value of k at which this root locus goes through this particular point, right? So therefore for the answer is there is no value of k at which the root locus goes through this particular point, right? So therefore this is one conceptual question from control systems, okay? Now if you use a magnitude condition, what is it that you get? So g of s into h of s, g of s into h of s. So this is nothing but k into s plus 3 into s plus 4 divided by s plus 1 into s plus 2, right? So if you use the magnitude condition, listen, before applying magnitude condition, check for angle condition, right? So angle condition fails here, right? So look at this one, k into, so listen, if you use the magnitude condition directly, you will get a finite value of k, and you will obviously end up with a wrong answer, right? So the understanding is that for no value of k, the root locus goes through this particular point, right? So this is how you solve this particular question, okay? Now let us move on to the next question. The Nyquist plot of the system is given in the figure below, and some frequency, so omega p, omega q, omega r and omega s is be the positive frequencies at the points p, q, r and s respectively. So where are the points? So this is q, this is p, this is s, right? This is s, okay? Now what is, okay, he is asking you to identify the gain crossover frequency, gain crossover frequency and phase crossover frequency. That is what they mean by GCOF and PCOF, right? So therefore gain crossover frequency and phase crossover frequency. So therefore the frequency at which the root locus passes through this unit circle, right? So this is the unit circle shown with dotted line. So therefore the frequency at which the root locus crosses the unit circle is nothing but the gain crossover frequency, right? Gain crossover frequency, and the frequency at which the root locus crosses the minus 180 degree axis. So this is nothing but the phase crossover frequency. So this point is nothing but s, right? So therefore omega s, and this point is nothing but omega q, right? So omega q is nothing but phase crossover frequency and omega s is nothing but gain crossover frequency, right? So this is how you solve this particular problem, okay? Now let us move on to the next question. So now we shall move on to the next subject, which is nothing but your digital circuits, okay? The following figure represents a combinational circuit having input variables x, y and z. The combination circuit's output is high for majority of the input bits, okay? Input bits high and output is low for majority of the input bits low, right? So you have three inputs, so therefore you have three inputs, right? So x, y and z, okay? And the output is nothing but f, right? So since you have three inputs, I list all the possible input combinations. So I'll start with 0 0 0 0 0 1 0 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1, okay? So these are the possible input combinations. So therefore the output will be high for the majority of the input bits high, okay? So here all the inputs are low, so therefore output will also be low, right? So majority inputs are low, so therefore output will be low. Here majority inputs are low, so therefore output will be low. Here also majority inputs are low, so therefore output will be low. Here the majority inputs are 1, right, are high, so therefore output will be high. Here the majority inputs are low, so therefore this is 0. Here the majority inputs are high, right? So you have two high inputs, so therefore output is high. Here also two inputs are high, so therefore output will be high, and here also obviously majority of the inputs are high, so therefore this will be right. So therefore F, so if you express it in canonical SOP form, so you have 3, listen, this is 3, this is 5, this is 6, and this is 7, right? This is 7, so therefore 3, 5, 6, 7, so therefore this is nothing but the canonical SOP representation of the carry output of a full adder circuit, right? Full adder circuit, and which we already know, which we have already simplified this. So what will be the simplified equation? So if you enter this into the K-map and simplify this, what is it that you get? Xy plus yz plus zx. So therefore what is the answer? C is the correct answer, right? So this is how you solve this particular problem. Okay, now let us move on to the next question. So in the given circuit, if Z is connected as carry, if Z is connected as carry, if Z is connected as carry to the full adder, and if Z is equal to 1, so if this is 1, right, so therefore Y and Z are the inputs to the XOR gate, right, so therefore what will be the output of this one? So Y Z bar plus Y bar Z, right, so therefore this becomes 0, and therefore Y bar into Z is 1, so therefore this will be Y bar. Okay, so the input to the full adder is Y bar, and the other input is X, and the other input is 1, right? So therefore the output of the full adder, so the output of the full adder will be, what will be the output of full adder? So listen, so this is nothing but sum is equal to X plus Y bar plus 1, right? X plus Y bar plus 1, so therefore this I can write it as Y bar, I'll write it as just 1's complement, right? So 1's complement of Y plus 1, right? So therefore this is nothing but 1's complement plus 1 is nothing but 2's complement of Y, right? 2's complement of Y, so therefore this is nothing but X minus Y, so therefore this entire circuit will behave as a subtractor, right? So this entire circuit will behave as a subtractor, right? So therefore this is how you solve this particular problem. Now let us move on to the next question. So what is the maximum frequency for clock in megahertz, right? So what is the maximum frequency for clock in megahertz? So here the propagation delay of each of the flip-flops is given as, the propagation delay of flip-flops is given as 2 nanoseconds, right? So let us see the sequence of events. So first I'll draw the clock cycle, so therefore this is the clock cycle, right? So first I'll call this flip-flop as D1 and this flip-flop as D2, right? So positive edge triggered clock are used, so therefore I'll also mark the positive edges, right? So therefore first I'll check for D1. Okay, I'll check for D1. So listen, what are the sequence of events that should occur between two positive edges? So what are the sequence of events that should occur between two positive edges or in one clock duration? So look at this one. It has to listen, it has to get the input from this one, right? So therefore obviously you have to wait for the propagation delay of the flip-flop D2, right? So therefore this is nothing but propagation delay of flip-flop D2, right? And then you have to wait for the propagation delay of this AND gate, right? So AND gate has a propagation delay of 1 nanosecond, and propagation delay of D2 is 2 nanoseconds. And what is the setup time of D1? D1 is nothing but, so D1 setup time of D1 is nothing but 2 nanoseconds, right? So listen, this is nothing but the propagation delay of flip-flop D2, and this one is nothing but propagation delay of the AND gate, right? So this is a propagation delay of AND gate, so this is 2 nanoseconds and this is 1 nanosecond. And what is this one? So this is nothing but the setup time of D1, right? So this is nothing but the setup time of D1, which is nothing but 2 nanoseconds, right? So therefore these are the sequence of events that should occur in between two positive clock edges, right? So therefore the clock duration should be at least this duration, right? So there is 2 plus 1 plus 2, right? 2 nanosecond plus 1 nanosecond plus 2 nanoseconds, so 5 nanoseconds, right? So this is for D1. Now let us look at D2, right? Let us look at D2. So look at this one. D2 will get, so I'll also mark the clock edges. So again positive edges, so I'll mark the positive edges. So what are the sequence of events that occur between two clock edges? So look at this one. Listen, at the positive edge, so this has a readily input available to this particular flip-flop, right? So therefore, listen, it has to wait for the propagation delay of this one. So therefore, this is a propagation delay of the first flip-flop. This is propagation delay of first flip-flop. And what is the setup time of this one? So setup time of this one is nothing but 2 nanoseconds, right? So setup time of D2. So this is nothing but the propagation delay is 2 nanoseconds and the setup time of this is nothing but 2 nanoseconds. So therefore, the clock duration should be at least of duration 4 nanoseconds, right? So this is nothing but D2, right? This is for D2, right? So I have done it for both the flip-flops. So which path decides, which critical path decides the clock duration? So listen, you have to take the maximum of these values. So this is nothing but 5 nanoseconds. So therefore, the clock duration should be equal to 5 nanoseconds, right? Which is nothing but maximum of 5 nano and 4 nano, right? So this critical path decides the clock frequency. So therefore, so 5 nanoseconds. So once you get the clock frequency, you can easily get the clock period. You can easily get the clock frequency 1 by 5 nanoseconds. So therefore, 10 raised to 9 by 10 raised to 9 by 5, and you have to express it in megahertz, right? So therefore, I can write it as 10 raised to 3 into 10 raised to 6. So therefore, this is nothing but 1000 by 5. So therefore, 200, right? 200 megahertz. Okay, so the answer to this particular question is nothing but 200 megahertz, right? So this is how you solve this particular problem. Now let us move on to the next question. So this is from solid state devices, which is pretty simple. So you are asked to identify the n-type dopants. Okay, what are the n-type dopants? So what are the fifth group elements? Fifth group elements are nothing but the n-type dopants. So therefore, pick the fifth group elements. Phosphorus is fifth group and arsenic is also fifth group, whereas boron and gallium are third group elements, right? Third group elements, whereas phosphorus and arsenic are fifth group elements. So therefore, the correct options are B and C, right? So straightforward, simple question. Now, what is he asking you to calculate? Ni, intrinsic concentration. Intrinsic carrier concentration is given to you 2.5 into 10 raised to 16. So 10 raised to centimeter minus, listen, this is nothing but this printing mistake. So there is no 1 here. Centimeter raised to minus 3 or per centimeter cube. Mu n is also given to you. Okay, mu n is also given to you and mu p is also given to you. Okay, and he is asking you to find the intrinsic resistivity. Okay, he is asking you to find the intrinsic resistivity. So therefore, intrinsic resistivity is nothing but the reciprocal of the conductivity, right? So what is conductivity? So conductivity is nothing but Ni Q into, listen, this is an intrinsic semiconductor. So therefore, mu n plus mu p, right? So because look at this one, this is nothing but n q mu n plus p q mu p, but they have asked for our intrinsic semiconductor. So therefore, n is equal to p is equal to ni. So therefore, I will take ni into q common. So ni into q common. So mu n plus mu p, right? So therefore, that is how you get this. Okay, so what is Ni? So Ni is nothing but 2.5 into, listen, the answer you have to enter it in kilo ohm meter, right? So kilo ohm meter. Okay, now 2.5 into 10 raised to 16. Okay, 2.5 into 10 raised to 16 into Q is nothing but 1.6 into 10 raised to minus 19. Okay, and mu n and mu p. So this is nothing but 0.15 plus 0.05, right? So now you have to be consistent with the units. So if you look at this one, mu n and mu p are given in meter square per volt second. Okay, whereas Ni is in centimeter per centimeter cube, right? Per centimeter cube. So you have to convert this into meters, right? So listen, we know that once you have to convert this into meters, right? So 1 centimeter is equal to 10 raised to minus 2 meters. Okay, 1 centimeter is nothing but 10 raised to minus 2 meters. So therefore, listen, Ni is nothing but 2.5 into 10 raised to 16 per centimeter cube, right? So 2.5 into 10 raised to 16, 10 raised to 16 per, listen, so you can write this as 10 raised to minus 6 meter cube, right? 10 raised to minus 6 meter cube, because 1 centimeter is nothing but 10 raised to 2, 10 raised to minus 2 meters. So therefore, this is nothing but this when this minus 10 raised to minus 6 goes to numerator, it becomes 2.6 into 10 raised to 22 per meter cube, right? So now all of them are in meters, right? So therefore, and the answer you need to get is also in meters, right? So therefore, you have to multiply this with, you have to multiply this term with 10 raised to 6, right? So therefore, solve this, it comes out as 1.25 kilo ohm meter, right? So 1.25 kilo ohm meter. Okay, so listen, you have to be consistent with the units. So these two quantities are in meter square, and this in meters, and this is in centimeters, right? So therefore, that's how that's why I have converted this into meters, right? So the answer is also as in meters, right? So this is how you solve this particular problem. Now let us move on to the next question. An electric field of intensity. So electric field intensity, how did I identify that this is electric field intensity? Look at the units. The units of electric field intensity is volt per meter. So E is equal to 0.01 volt per meter. Okay, is applied along a length of copper wire of circular cross section, okay, of circular cross section, and with a diameter, diameter is given to you 1 millimeter. Conductivity is also given to you, which is nothing but 5.8 into 10 raised to 7 Siemens per meter. Current flowing through wire, okay, current flowing through the wire. Listen, so using the same setup, we have derived the Ohm's law in field theory, right? Ohm's law in field theory. So therefore, current density is nothing but current per unit cross sectional area, right? So therefore, I by A. So what is it? What is he asking you to calculate? The current through the wire, right? So therefore, if you use this equation, I is equal to sigma into E into A, right? So sigma is given to you, conductivity is given to you, E is given to you, and you can find the area of a circular cross section, right? So conductivity is given to you as 5.8 into 10 raised to 7 into E is nothing but 0 point. Listen, this is in Siemens meter, right? So therefore, this is also in meter, volt per meter. So therefore, 0.01 into A. Area of cross section. So area of cross section is nothing but pi r square. So therefore, pi into r is nothing but d by 2, right? So r is nothing but 1 by 2, that is 0.5 millimeters, right? So therefore, 0.5 into 10 raised to minus 3 whole square, right? So therefore, pi into 0.5 into 10 raised to minus 3 whole square, right? So when you solve this, please do this calculation. I don't have the answer with me, so this is the simplification that you have to do. So do it for yourself. So this is how you solve this particular problem. Okay, now let us move on to the next question. So in germanium, mu n is given to you. Okay, in germanium, mu n is given to you. Mobility of the electrons is given to you. So this is given as meter square per volt second, 0.38 meter square per volt second, and dn is nothing but is what you need to calculate. So you can use the Einstein's relationship. So dn by mu n is equal to Vt, right? So dn is equal to mu n into Vt. Okay, mu n is nothing but 0.38 into thermal voltage Vt at the room temperature is approximately equal to 26 millivolts, right? So therefore 26 milli, okay, 26 milli. So if you use this, that is, listen, what you get is dn in meter square per volt second, right? Meter square per volt second, but he is asking you to enter the value of dn in terms of centimeter square per volt second, right? So what you need to do is you have to convert this into centimeters. So how do you convert that? So this multiply it with 10 raised to 4, right? So that becomes centimeter square per volt second, right? So therefore, that gives you the answer. So when you solve it, it comes out as 98.04 something, right? 98.04 centimeter square per volt second. Okay, this is how you solve this particular problem. Okay, now let us move on to the next question. Consider an FM signal. Consider an FM signal. F of t is given to you. Okay, AC and FC are respectively the amplitude and frequency of the carrier waveform. The frequency f1 is in hertz, okay, f1 is in hertz, the peak frequency deviation. Okay, so how do you calculate the peak frequency deviation? First you have to calculate the instantaneous frequency, and so fc plus, so this is the peak frequency deviation, that is the maximum value of the frequency deviation is what is asking you to calculate, right? So how do you calculate the instantaneous frequency? Instantaneous frequency is equal to fi is equal to 1 by 2 pi into derivative of the phase, right? So derivative of the phase. So what is theta of t? So this is nothing but the argument, right? So the argument inside the cos function is nothing but the theta of t, right? So therefore 1 by 2 pi into derivative of this is nothing but 2 pi fct plus 3 sine 2 pi f1 into t plus 4 sine 6 pi f1 into t, right? So now differentiate this and divide with 2 pi. So when you differentiate the first term, what is it that you get? 2 pi fc. And what about this one? What about the second term? So derivative of the second term is nothing but 3 into 2 pi f1 into cos 2 pi f1 into t, because derivative of sine is nothing but cos. And similarly here also 4 into 6 pi f1 into cos 6 pi f1 into t, right? So now what will be the first term? So this is nothing but fc, and listen, you can take 2 pi common from all the terms. So what is it that you get? So 3 f1 into cos 2 pi f1 t, and this one is nothing but 6 pi by 2 pi is nothing but 3 pi, 3 pi into 4 is nothing but 12 pi, right? 12, right? So 12 f1 into cos 6 pi f1 into t, right? So now when you compare both this, so all you need to get is the maximum value of this one, right? So maximum value of this one. So what is the maximum value of cos function? So maximum value of cos function is nothing but, so therefore listen, the maximum value of this term is nothing but 3f1 plus 12f1, which is nothing but 15f1. So the answer is C. Okay, so this is how you solve this particular problem, right? Now let us move on to the next problem. So this is from information theory and coding. Okay, he is asking you to calculate the minimum Hamming distance. Okay, minimum Hamming distance. So listen, if you look at the generator matrix, so the first 3 columns is nothing but the identity matrix, right? So therefore this is nothing but I 3 by 3, right? And obviously this one will be the parity matrix, right? So P, what will be the order? So this is nothing but I k by k, and parity matrix has a order of n by k by k, right? N by k. So therefore looking at this one, so this is nothing but 3 by 3, right? So therefore n minus k is equal to 3, and clearly k is equal to 3, so therefore n is equal to 6, right? So therefore they are talking about a 6,3 linear block code, right? So 6,3 linear block code, right? So now how do you calculate the d minimum? So k is nothing but 3, right? So k is nothing but 3. So therefore how many valid code words that we get? So 2 raised to k, 2 raised to 3 is nothing but 8, right? So therefore what are the valid code words that we get? So listen, for what are the possible input combinations? Look at this one. The message is of 3 bits, right? So message is of 3-bit length. So therefore what are the possible input message combinations? So that 000, 001, 010, 011, 100, 101, and 110 and 111, right? So there 0, 1, 2, 3, 4, 5, 6, 7. Okay, and if you look at the parity matrix, so listen, so how do you get the parity bits? So parity, so you can clearly see that, so parity bit P1 is nothing but this is nothing but the linear combination of D1 and D3, right? So listen, we know that this entire thing is nothing but your code word, right? So this entire thing is nothing but your code word. So all you need to get is the parity bits. Okay, all you need to get is nothing but the parity bits. So how do you get the parity bits? So if you look at the parity matrix, so P1 is nothing but the linear combination of D1 and D3, right? So this is D1 and this is D1, okay, this is D1, this is D2, and this is D3, okay. So P1 is nothing but D1 XOR D3, right, and P2 is nothing but D2 XOR D2 XOR D3, okay, and P3 is nothing but D1 XOR D2, right. So or else you can also use this one, right. So C bar is equal to data word into the generator matrix, right. So you can just multiply this with the corresponding generator matrix to calculate the corresponding code word, right. So corresponding code word, so that's one way of finding the code words. And listen, for the linear block code, we have learned that we have a property for linear block code that minimum Hamming distance is nothing but the minimum weight, okay. Minimum Hamming distance is nothing but the minimum weight of the code word. So therefore what I'm going to do is I'll calculate the code word for each of these inputs, and I'll look at the minimum weight, okay. So therefore what is this one? So listen, one way of doing is using the matrix multiplication. The other way of doing finding the code words is this, right. So P1 is nothing but D1 XOR D3, right, D1 XOR D3, so 0 XOR 0, this is 0, this is 0, this is 0, because all are zeros, right. And what is P1? P1 D1 XOR D3, so this is 1, D2, so this is nothing but D2 XOR D3 is also 1, and what about this one? D1 D2, this is 0, okay. What about this? So this is nothing but 0 XOR 0, 0 XOR 0, this is 1 XOR 0, and D1 XOR, this is 1, okay. What about this one? 0 XOR 1, D2 XOR D3, this is 0, and this is 1, right, this is 1. And what about this one? This is 1, and this is 0, and this is 1, okay, this is 1. And what about the 1 XOR 1 is 0, okay, and this is nothing but 1, and D1 D2, this is also 1, okay. What about this one? 1 1 XOR 0 is 1, okay, D2 XOR D3 is 1, and what about this one? 1 XOR 1 is 0, okay. And here this is 0, this is 0, and this is 0, okay. So you have to look at the code words except all 0 code word, right, except all 0 code word, and get the minimum weight of each code word. So how many number of ones do you have to calculate the Hamming weight? So listen, for linear block codes, minimum distance is nothing but the minimum weight, right. So therefore what is the Hamming weight? So number of ones, so this is nothing but 3. In this case it is nothing but here 1 2 3, this is also 3, and here it is 4, right. So here is 1 2 3 4, okay, and here it is 1 2 3, right. So this is 3, and 1 2 3 4, this is 4, and 1 2 3 4, this is 4, and this is 3, right. So the minimum value is nothing but 3, so therefore the minimum Hamming distance is equal to 3, right. So this is how you solve this particular problem, okay. Now let us move on to the next question. So the random variable x takes -1, 0, and 1 with probabilities. So x of probability of x taking -1 is equal to alpha, probability of x taking 1 is equal to alpha, and probability of x taking 0 is equal to 1 minus 2 alpha, okay, where the value of alpha lies in between 0 and 1 by 2. Let g of alpha represents the entropy of x parameterized by alpha. Which of the following statements are true, right? So listen, we already know that the entropy will be maximum when the symbols are equiprobable, right? You have 3 symbols, and obviously if they are equiprobable, that is if the value of alpha is equal to 1 by 3, right? So therefore this is 1 by 3, this is 1 by 3, obviously 1 minus 2 into 1 by 3 is nothing but 1 by 3, right? So when all the symbols are equiprobable, right? So when all the values are equiprobable, the entropy will be maximum, right? So entropy will be maximum. So here the entropy is represented with g of alpha, right? So therefore g of alpha will be maximum when the value of alpha is equal to 1 by 3, which is nothing but 0.33, right? So we know that listen, so this is nothing but the probability, and this is nothing but the h of p, right, entropy, and we have learnt that the entropy will be the plot of entropy versus probability. This is the maximum value of entropy which occurs at the equiprobable condition, right, at which occurs at equiprobable condition. So this is nothing but 1 by 3, right. So you can clearly see that. Look at the first option, g of 0.5. So 0.5 is nothing but, so this is 0.3, so 0.25 will be in this region. So g of 0.25 is greater than 0.3, which is absolutely wrong, right. So this is false, right, because this is a value which is lesser than this value, right. So therefore option A is wrong. G of 0.3 is greater than g of 0.5. Yes, this is true, right. So the value, so this is nothing but 0.25. At 0.25 the entropy value is this one, and at 0.3 the entropy value is this one. So therefore obviously the value at 0.3 is greater than 0.25, right. So this is true. The value at 0.3 is greater than 0.4. So 0.4 is somewhere here. So again this value is less than the entropy value at 0.3. So therefore option C is also correct. What about this one? 0.4 greater than 0.3? No, entropy at 0.4 is greater than 0.3, which is also false, right. So therefore this option, so this is our MSQ question. So option B and D are correct. Okay, now let us move on to the next question. So if Z0 is equal to 50 ohm, ZL is equal to, listen, you have a transmission line, okay, you have a transmission line of characteristic impedance 50 ohm, okay, and you have a load connected to the transmission line. What is the load? What is the value of the load? ZL is equal to 50 minus J 75 ohms, okay, and he has given that the incident power, so the incident power is nothing but 10 milliwatt. Okay, what is the power delivered to the load? What is the power delivered to the load? We have already learned that power delivered to the load is nothing but the power incident minus the power reflected, right, power reflected. Okay, so power incident minus power reflected, and we have derived a relation. So power incident power into 1 minus magnitude of the reflection coefficient, right. So this is nothing but reflection coefficient whole square, magnitude of the reflection coefficient whole square, right. So therefore input power is given, all you need to find is the magnitude of the reflection coefficient. So reflection coefficient is nothing but ZL minus Z0 by ZL plus Z0, right. So ZL is nothing but 50 minus J75 minus 50 divided by 50 minus J75 plus 50, right. So this is nothing but minus J75 by 100 minus J75, right. So if I take out 25 common from the denominator, so minus J75 by 25 into this becomes 4 and this becomes 3, right. So this becomes 3, right. So therefore if you take the magnitude, so if you take the magnitude of the reflection coefficient, so this is nothing but 3 by 5, which is nothing but 0.6, right. So this is equal to input power is given as 10 milliwatt, okay, 10 milliwatt into 1 minus 0.6 whole square, right, 1 minus 0.6, so 0.36, so 1 minus 0.36 is 0.6464 into 10, so therefore 6.4 milliwatt, right. So this is how you solve this particular problem. Okay, now we shall move on to the next problem. So look at this one. You have questions from, so this is not math, so this is aptitude, right. This is aptitude. So you have to find the missing numbers. So 3 comma 9 comma 19 comma 33 and find the next missing number, right. So first I'll try to find the difference between the consecutive numbers. So 9 minus 3 is nothing but 6, okay, 9 minus 3 is nothing but 6, 19 minus 9 is nothing but 10, 33 minus 19, okay, 33 minus 19, so this is nothing but 33 minus 19 is nothing but 14, right. Now again, so listen, I don't see any pattern here, so therefore the difference here is nothing but, the difference here is 4 and the difference here is also 4, right, the difference here also 4. So therefore listen, the next difference should also be 4, right. So therefore 4 greater than 14, so this should be 18, right. So therefore listen, so the difference between this missing number and 33 should be 18, right. So therefore the next number should be 33 plus 18, right? So 33 plus 18 is nothing but 8 plus 3 is nothing but 11, right? So therefore this is 51. Okay, so the missing number is 51. Okay, now let us move on to the next question. The rank of the following matrix to have at least 3. So the rank of this matrix, A should be greater than or equal to 3, right? So the rank of the matrix should be at least 3. So for what values of alpha, beta and gamma, the rank of this matrix will be at least 3, right? So now we will check the condition. So look at this one. If all the 3 values are non-zero, listen, the matrix is already in echelon form, right? So you don't have to reduce this. So all you need to find is a check the options, right? So if you have all the values non-zero, right, obviously the rank of this matrix will be 4, right, which satisfies this one, right? So therefore this satisfies the given condition, right? So therefore option A is a possible answer, right? Now alpha equal to 0, beta equal to 0 and gamma equal to 0. So in that case what happens, the rank of the matrix will be equal to 2, right? So which does not satisfy the condition, so therefore option C is not correct. Okay, now what about this one? Alpha is equal to 0, beta not equal to 0 and gamma is equal to 0, right? Gamma is equal to 0. So listen, in that case what happens, the rank of the matrix will be equal to 3, right? So this also will satisfy the condition, right? With this also satisfy the condition. So therefore I think this is MSQ. So therefore option A and B satisfies a given condition. So therefore A and B are correct, right? A and B are correct. Okay, now let us move on to the next question. A bag has 4 balls in which 2 are red and 2 are blue. Find the probability of picking 2 different colors when 2 balls are drawn without a replacement, right? So you have to find the probability of picking 2 balls. Okay, so you have red and blue ball. Okay, you have 2 red balls, and 2 blue balls, right? So first I'll find this possibility, that is first I'll pick a red ball and then blue ball, right? And there is one more possibility, first I'll pick blue ball followed by red ball. Okay, so what is the possibility? So what is the possibility of picking red ball first? So in total you have 4 balls, right? So in total you have 4 balls, and what is the probability of picking red ball? So you have 2 red balls, so 2 by 4. Okay, followed by blue ball. Listen, now how many balls are left in the bag? So you have 3 balls, and what is the probability of picking what is the probability of picking blue ball from these 3 balls? Since you have 2 blue balls, so therefore this is 2 by 3, right? So this is one possibility. Now what is the other possibility? So blue followed by red, right? So out of 4 balls, what is the possibility of picking a blue ball? Since you have 2 blue balls, so 2 by 4 followed by what is the possibility of picking a red ball? Listen, how many balls do you have in the bag? So you have 3 balls. Out of 3 balls, what is the probability of picking a red ball? Since you have 2 red balls, so 2 by 3, right? So you simplify this, the answer will be equal to, so 2 into 2 into 2 by 4 into 3, so 8 by, or this becomes 2 by 3, right? This is nothing but 2 by 3, right? This is how you solve this particular problem. Okay, now let us move on to the next question. So look at this one. F of x is equal to minus modulus of x by x. Listen, in signals and systems we have already learned that magnitude of x by x, so this is nothing but the signum function, right? This is nothing but the signum function. Okay, now if you multiply this with negative sign, what do you get here? So this is 1 and this is minus 1, right? So you are multiplying this with minus 1, so what is it that you get? So this becomes this will be minus 1 and this is 1, right? So this is the, he is asking you to plot this particular function. Okay, or else listen, if you don't know the signum function, so this is nothing but the signum function, right? So if you don't know this, so how do you solve this one? So f of x is equal to x for x greater than 0, magnitude of modulus of x is equal to x for x greater than 0, and it is minus x for x less than 0. Okay, so therefore x minus x by x is nothing but minus 1. Okay, and for x less than 0, what happens? So this is minus x, so therefore x by x is 1, right? So therefore you get this one. Okay, so this is how you plot this particular function. Okay, now let us move on to the next question. two dice are thrown and let x denote the sum, then you are asked to find the expectation of x. So expectation of x, is nothing but x into p of x, right? So therefore you need to get the probability mass function, right? So therefore first I'll find out the possible values that x takes. So x is a random variable, so they have defined x as a random variable, so which represents the sum of the values on the two dice, right? So what are the possible values of x, what are the possible values that x takes? So x takes, so listen, if you get 1 comma 1 on both the dice, so what is the value of x? X is equal to 2, right? So you can also get 2 comma 1 and 1 comma 2, right? So therefore x can also take 3, 4, 5, 6, 7, 8, 9, 10, 11, and what is the maximum value that x can take? 12, right? Because you have you get 6 comma 6. Listen, when you get both 6 on both the dice, the value of x represents the sum, right? So therefore the value of x will be 12. Okay, so what is the probability that x takes 2? Listen, what is the sample space? So you have two dice, so therefore the sample space, how many how many entries do you have in the sample space? 36 entries, right? So what is the probability that the random variable x takes 2? So out of 36 entries, so this is a one possible favorable case, right? So 1 by 36, right? So 1 by 36. Okay, and what about this one? What is the probability that the random variable takes 3? The random variable x takes 3. So therefore listen, these are the favorable cases out of 36. So therefore 2 by 36, right? Now similarly this is 3 by 36, this is 4 by 36, this is 5 by 36, this is 6 by 36, and this is 5 again. It's again decreases, right? So 5 by 36, 4 by 36, 3 by 36, 2 by 36, and 1 by 36, right? So just substitute into this equation, so you will get the value of the expectation. So this is nothing but x into p of x, right? So therefore this product 2 into, so 2 by 36, okay, plus 2 into 3, so 2 into 3, 6 by 36, plus 12 by 36, plus 20 by 36, plus 30 by 36, plus 42 by 36, plus 40 by 36, plus 36 by 36, plus 30 by 36, plus 22 by 36, plus 12 by 36, right? So when you solve this, it comes out as 7, right? It comes out as 7. Okay, so you have also a direct formula, which is nothing but expectation of this is nothing but 7n by 2, where n is the number of dice thrown. So therefore here you have 2 dice thrown, so therefore the value of n is equal to 2. So this is nothing but 7 into 2 by 2, which is 7, right? So which is direct, but you need to remember this. If you don't remember this, this is how you solve this particular problem. Okay, now let us move on to the next problem. Given f of x is equal to, 2x cube minus 3x square minus 12x plus 1. Okay, he's asking you to find the maxima and minima. Okay, so this is a function of a single variable, right, x. So first I'll calculate the first derivative. So f dash of x is nothing but 6x square minus 6x minus 12. Okay, now listen, I want to find the stationary point, so therefore I will equate f dash of x is equal to 0. So 6x square minus 6x minus 12 is equal to 0. So x square minus x minus 2 is equal to 0. So quadratic equation, what are the roots of this quadratic equation? X is equal to 2 and minus 1, right? X is equal to 2 and minus 1. Okay, now so what is it that you get here? So this is nothing but, so x is equal to 2. So roots of this are nothing but x minus 2 into x plus 1, right? So okay, and this is nothing but 2 and minus 1. And tell me what about the second derivative? So f double dash of x is equal to, so this is nothing but 12x minus 6, right? 12x minus 6. Now what will be the double derivative at x is equal to 2? So this is nothing but 12 into 2. 12 into 2 is 24 minus 6 is nothing but 18, which is positive, right? So if double derivative is positive, right? So obviously x is equal to 2 should be a minima, right? It should be a minima. Okay, it should be a minima, and so here it is given as x equal to 2, it is given as local maxima, so this is false. Okay, and what about the second derivative at x equal to minus 1? So f double dash of x at x is equal to minus 1, so this is 12 into minus 1, so minus 12 minus 6 is equal to minus 18, which is negative, right? So at x equal to minus 1, the double derivative is negative, so therefore essentially x equal to minus 1 is nothing but local maxima, right? But here it is given as local minima, right? So this is also not the correct answer, right? So we are not sure about the options, right? So listen, in order to find the global maxima and global minima, you need to know the range of x in which the function f of x is defined, right? So only then you can calculate the global maxima and global minima. So we wait for the official paper to check the options, right? So here according to these options, listen, the range of this function should have been mentioned, right? So in order to calculate the global maxima and global minima, right? So now we shall move on to the next question. So given t square into y double dash of t minus 2t into y dash of t plus 2 into y of t is equal to 0. Okay, y dash of 0 is equal to 1, y dash of 1 is equal to minus 1, right? So this is a Cauchy-Euler differential equation, right? So this is a Cauchy-Euler differential equation. So all you need to get is the auxiliary equation, right? So therefore you can replace this with d into d minus 1 into y, okay, minus 2 into d into y, right, plus 2 into y, so this is equal to 0, right? So therefore d into d minus 1 minus 2d plus 2 into y is equal to 0. So d square minus 3d plus 2 into y is equal to 0, right? So what are the roots that you get? So you get the roots as 2 and 1, right? 2 and 1. So therefore y is equal to, listen, y is equal to, what is it that you get? So c1 into, suppose for example you have taken this as ds z, so d dou by dou z, so therefore e raised to z, right, e raised to z plus c1 into e raised to 2z, right? So where t is equal to e raised to z, right? So I hope you know the Cauchy's Euler differential equation, right? So this is nothing but this is y. So how do you express y in terms of t? So y of t is equal to c1 into e raised to z is nothing but t. So therefore t plus c2 into e raised to z whole square, right? So t square. Okay, so you have to find the maximum value of y of t over 0 to 1. Okay, so you have to find the, you can only find the maximum value of y of t provided you know the values of c1 and c2. In order to find the values of c1 and c2, they have supplied with extra information, that is derivative of y of t at t is equal to 0 is 1. Okay, so differentiate this. So y dash of t is equal to c1 plus 2c2 into t. So y dash of 0 is equal to c1, so this is equal to 1, okay, because t is equal to 0. Now y dash of 1 is equal to c1 plus 2c2 is equal to minus 1, okay. So c2 is equal to minus 2 by 2, which is equal to minus 1, right. So therefore I got the values of c1 and c2. So therefore y of t is equal to, look at this one, c1 is 1, so therefore t, c2 is minus 1, so therefore minus t square. So now it is straightforward, right. So y of t is equal to t minus t square. So all you need to do is find the maximum value. So how do you do this? So how do you do this one? Y of t is equal to t minus t square. So derivative. So derivative of y of t with respect to t is nothing but 1 minus 2t. Okay, and you can clearly see that if you take the second derivative, so d square y of t by dt square, this is equal to minus 2. So obviously this point is a stationary point, and at this particular value you have a maxima because the second derivative is negative, right? So therefore when you equate it to 0, t is equal to 1 by 2, right? So you know at the value of t equal to 1 by t you get a maxima. So you are asked to find the maximum value. So all you need to do is substitute t is equal to 1 by 2 into this equation. Okay, so y of 1 by 2 is equal to 1 by 2 minus 1 by 2 whole square 1 by 4, right? So which is equal to 1 by 4, which is equal to 0.25, right? Now let us move on to the next question. So the next question is from English. Had I been active as a child, I dash a famous actor, right? So had I been active as a child, I could have been a famous doctor, right? I can be a famous doctor, no, right? I will be a famous doctor, no. I might be a famous doctor, no. I could have been, right? So had I been active as a child, I could have been a famous actor. Okay. Now next question. Abuse, insult, ridicule. Okay, so you have to find the relationship between these three words. Okay, abuse, insult and ridicule. So abuse is a severe form of hurting a person, right? So insult is a slighter version of insult, right? So and followed by ridicule. This is again, listen, you can clearly see the decreasing level. Okay, so you can clearly see the decreasing level of this thing. So similarly you have to find the decreasing level of relation here as well. So if you look at the options, extol, okay, extol, praise and appreciate also follows the same decreasing level of intensity. So we shall move on to the next question. Okay, so here B is the option. So okay, these are the questions that we have. Okay, so we have completed the memory based questions. Okay, so these are the 42, these are the questions that we have collected from the students. Okay, so still there are few more questions. So we will publish the official answers once the official paper, okay, will release the key once the official paper is published. Okay, now with this I'll end the session. Hope you have done well. Thank you.